by design, one feature is it's a non-pressurized, so if we introduce water very slowly into the chamber, instead of from the top being drainage, the water starts to rise in the chamber, but before it can exit to the following chamber through the 2-inch connection over here, it has to overflow the inner hole. And when that happens, the overflow is going to occur right about now. It quickly goes into that 2-inch gravel layer and flows laterally very quickly. So even though the chambers may be 6 feet apart or 4 feet apart, you have that lateral movement. Now the beauty of sand, and it's the only substance that does it consistently, is what we call capillary rise. Because sand now intersected that gravel layer, but that intersection line is below my spill line, I really created a little head pressure to push the water sideways, and now sand takes over the action. Sand starts that capillary rise, and in the process you have a mixture of water and oxygen being created in the root zone. Now capillary rise is a slow process. It's like watching paint dry. Some sand's a little quicker in the first couple inches, but then they slow down. What we look for in a typical epic profile, if we're growing turf, the profile might be 15 inches deep, but it's going to take 12 to 18 hours for that water to reach the surface. And that capillary action will keep on moving even further. This column of the same sand is several years old. Its maximum capillary rise is right about here. It's about a 16-inch level. But it took months to reach from here to here. It's a very slow process because we're competing with the evaporation rate from the surface. So being indoors in a cool environment, it rises. But this column of sand now is locked up in a sand profile, and it doesn't drain anymore because it's not at saturation. The only way I can withdraw this oxygenated sand is by plant growth. So as plants grow, the water disappears, and then I can add more water in the profile. So even in desert environments, irrigation with EPIC only occurs once a week. We recharge the water, it travels up the profile becomes a giant sponge. It actually holds 2.5 gallons of water per square foot of area. And then the plants are the computers that decide how much water they need. If they need a lot of water, the roots are a little deeper. If they need less water, they transpire less. And that's the simplicity of it. There's no complexity, there's no moving part, there's no pressure lines. Things just grow like nature intended. The plants use up the water as they need it. And you can grow any type of plants. In the last 15 years in EPIC, we grew everything from pineapple to banana trees to palm trees to every type of tree that we could think of, every type of vegetable, every type of flower you could think of. Because the roots imitate soil. This is how plants evolved. But now the soil is very aerobic. And this is what's important in plant growth. You need a high oxygen level in the root zone because biologically they need oxygen and not just water to grow in.